Hello guys, how are you today? So today I will be explaining a summary of chapter 7. So chapter 7 summary. My apologies. Let me just change the font. Okay? So chapter 7 summary, okay? So chapter 7 is a really small chapter. We don't have to know a lot. The only thing we need to know is that there are 3 subatomic particles. Now, I'm pretty sure we all know these 3 subatomic particles. You probably don't know them by name because we never used to denote them as subatomic particles. But in fact, they are, first of all, the electrons, then the protons, then the neutrons. Okay? So what we need to know about the electrons is that their charge is -1, the protons have a charge of +1, and the neutrons do not have a charge. Whereas in the case of mass, the electron has a mass of 1/1840 AMU, whereas the protons have a mass of 1 AMU and the neutrons have a mass of 1 AMU. Okay, so these are like some of the main things we need to know. Also, you need to remember this, where we had X, A, and Z. We know that X refers to the chemical symbol. Alright. A refers to the mass number, and the mass number is what? It is neutrons plus protons. And then we have Z. Z is the atomic number or the number of protons. Alright, so this is the first page done. The next page we discuss something called isotopes, okay? First of all, what are isotopes? I'm gonna write a definition of isotopes, then we are gonna discuss in general what they are. So isotopes, they are atoms, okay, of the same element having the same atomic number but different mass number. Okay, so isotopes, they are atoms of the same element. So let's take an example. Any example. It could be, for example, carbon. Carbon, which is a really famous example of isotopes. So we know that carbon is usually, it has a mass number of 12 and an atomic number of 6. Now, an isotope is going to be the same element first of all. So it's going to be carbon, but it's going to have the same atomic number, so 6, but a different mass number, meaning it is going to be, instead of 12, probably 13. Now, what is changing in the isotopes? It's the number of neutrons. How do we know? We know that this on top, it is what? It is our mass number. And we know that the mass number is neutrons plus protons. So if it was originally 6 protons and the mass number was 12, and then the isotope is again 6 protons, but the mass number is 13, then definitely we are what? We are adding neutrons. Okay? So after isotopes, we move on to a calculation part. The calculation part is not so much. So what we need to calculate is the average atomic mass. Now to calculate the average atomic mass, we have to memorize an equation, which is, if you want, the sum. This is the sigma notation. Okay, please do not make any jokes out of it. I know how like childish you guys can be. Okay, like it's funny to make some jokes sometimes, but like please don't overdo it. So I don't mind you making any comments about this, just like don't over exceed the limit. Okay, so what does sigma stand for? It stands for the sum of, okay, so it is sigma, or the sum of given mass, okay, times the abundance over 100. Okay, so this is one format of writing it, or another format, let me just open another page, is given mass 1 times abundance 1 over 100, okay, plus given mass 2 times abundance 2 over 100. So you could do like denote it like this, or very simply just use the sigma notation. So sigma means the sum of given mass times abundance over 100. Alright, so this is the literally only equation that we need. So I'm gonna draw like a basic structure of electron. So over here we have the nucleus, and in the nucleus we have protons and neutrons. Now the nucleus is usually really dense. Okay, now surrounding the nucleus, and the nucleus has protons and neutrons, there are many shells surrounding the nucleus, and each of these shells holds the electrons. Now these electrons, they will orbit the nucleus, and we call the layer that they orbit on clouds. So the electron clouds or the electron shells. Okay, so one thing you need to know is that the farther the shell is from the nucleus, then the stronger is the energy or the force of the energy. Okay, so we move on to a new page. Okay, so now we move on to something really nice, which is called electronic configuration. Okay, now what about electronic configuration? There are like many ways to do the electronic configuration. So I'm gonna start with the electronic configuration for the atomic numbers from 1 all the way until 20. So that is from hydrogen all the way to calcium. Okay, we can use this method of electronic configuration, which is the shells. And by the shells, we know that the first one can hold a maximum of 2, the second one can hold a maximum of 8, the third one can hold a maximum of 8, and the last one can hold a maximum of 2. So as an example, I'm going to choose any random element. So for example, Si, which has an atomic number of 14, okay, we are going to take 2 electrons from the atomic number, okay, because we know we're talking about the Si, the Si atom, and the atom is neutral, so it has the same number of electrons and protons. So the number over here, which is the atomic number, which is the number of protons, is gonna be the number of electrons because it is an atom. Okay, so first of all, we got rid of 2 electrons, so that's 14 minus 2, which is then 12. Now we get rid of 8, we will be left with 4. And very simply, we can put 4 over here. So like this, we would have finished what the electronic configuration of any of the atoms from 1 all the way until 20, or from hydrogen all the way until calcium. Now, the second way of electronic configuration, okay, it is the SPDF. Now, I know a lot of you don't like the SPDF rule, but it's, in my opinion, a really nice rule. So look how we are going to do. We're going to start with S. After S, you have S, then P. Then you have S, then P, then D. Then S, then P, then D, then F. Now you will put the numbers. So you start 1, 2, 3, 4. Here you start directly from 2, so 2, 3, 4. Here you start directly from 3, so 3, 4. And here you start directly from 4. So any of the atoms after 20, so from scandium all the way on, okay, you can find its electronic configuration using the SPDF. So let me choose any random atom. So for example, let us take krypton, Kr. It has an atomic number of 36. Now if we're going to follow the SPDF, we're going to have 1s. Now I forgot to mention one thing, is that S always has 2 electrons. Okay. P always has 6 electrons, or it can carry 6 electrons. D can carry 10 electrons, and finally F can carry 14. So we start with 1, S2. So from the number of electrons, which is the same as the number of protons, because why? It is a neutral atom. Okay, so number of protons equals number of electrons. So we are going to remove from it 2 electrons. So 36 minus 2, we are going to get 38. Sorry, not 38. My bad, 34. Okay, then after that we move on to 2s2. So we finished with 1s2, we move on to 2s2. So minus 2, we will get 32. So got rid of this. We will move on to 2p6. So 32 minus 6 is 26. So we get rid of this one. And then again, we have 3s2. That's 26 minus 2. We get 24. Okay, so we are left with 24 electrons. So we got rid of this. We move on to 3p6. So that's going to be 24 minus 6, which is 18 electrons. Okay, so we finished with this. We move on to 3d10. So now we are minus 10. We are left with 8 electrons. We move on to this one. It becomes 4s2. So 8 minus 2 is 6. And then finally 4p6. So as you can see, we finished, they filled in the place of all the electrons that can be filled in P, which is 6. Okay, so one thing I can tell you about the SPDF way, okay, is like P holds 6 electrons. So if you end up with P and you end up that it has 6 electrons, then definitely it is a noble gas. Because I'll tell you what, the noble gases, okay, they hold in their last shell, which is their valence shell, 8 valence electrons. Now, if you can see in the SPDF values, okay, we started with 1s. This is the first shell. Then this is the second shell. Then this over here is the third shell. Then you stop at the fourth shell and you add the number of electrons. You have 2 plus 6. 2 plus 6 is 8 electrons. And we know that if it holds 8 electrons in its valence shell, then it is definitely a noble gas. Now, another way than the SPDF rule, okay, I'm just gonna write it as other way, is this way. We know that always in the first shell it holds 2, then it will hold 8. Then for the rest of them, it will hold 18 electrons. So if we are gonna do krypton, which is 36, if we are gonna find its electric configuration using this method, it's gonna be 2, okay? Then after that 8, so we're already done with 10. Then after that we're gonna put 18, so 2, 8, 18. So this is all right now 28, and then in the last finally it is 8. So as you can see, in the last shell it holds 8 valence electrons, so it is a noble gas. Okay, now one thing we need to know is periods, which are also rows, okay, or groups, which is columns. Okay, so what do we know about periods and rows? They are very simply the number of shells. Now if I go back to any one, okay, so let us say for example the electronic configuration we did for the Si, which is silicon, and we need to find in which row or which period is silicon in. We're gonna see how many shells does it take. So this is 1 shell, 2 shell, 3 shells. So silicon Si it has 3 shells, or it has like its valence shell is in the third shell. That means it will be in row 3 or period 3. And the periods are horizontal, by the way, okay? So if you look on the periodic table, silicon Si is on the third period. And now if we did for Kr, okay, we know that it is 4, so its valence shell is the 4th shell, so it is in the 4th row. So if you look again, you will find Kr in the 4th row. This is pretty much it for the periods. Now, however, for the groups and columns, they are the number of valence electrons. So let's go up again. We know that for silicon, it has 4 valence electrons. That means it's gonna be in column, or the group which is going vertical, okay? 4. Now, let me just open the periodic table. So this is the periodic table, okay? So this is gonna be the first group, first column, second group, second column. These we discard them, okay? Yani, of course not what like these, we are gonna discard them all for now. Then this is gonna be the third column, the 4th, the 5th, the 6th, and then there's gonna be 7th and 8th behind. So if I move just a bit more, this is 7th and this is 8th. This is all you guys need to know, okay? So we were discussing about silicon. So silicon it has 4 valence electrons, so it's going to be in the 4th group. So if we go back here, we will check, okay, this is group 1, group 2, we're going to forget about these, then this is group 3 and 4, and as you can see, silicon is in group 4. Same goes to what? To the krypton. So krypton has 8 valence electrons, so it is definitely in group 8. So we are going to go back to the periodic table, and we will go to group 8, and we will find krypton over here. Okay? Now, one more thing I would like to discuss is core electrons. Okay? So, core electrons, they are strongly bound to the nucleus in the first shell. So let's say this is the nucleus, it has protons and neutrons. Then we have the surrounding shells, okay? There is gonna be some electrons on a specific shells. These are called what? Core electrons, because they are strongly bound to nucleus, okay, in the first shell. So they are usually found in the first shell, which is directly after the nucleus, okay, and they are like really strongly attracted to the nucleus. Now a little more about isotopes, okay, we're just gonna discuss some properties. We know that isotopes, they are what? They are of the same element, the same atomic number, but different mass number. Okay, so they all have, if we're talking about the isotopes of the same element, they have the same chemical properties, okay? So just know that isotopes of the same elements have the same chemical properties, okay? So carbon, for example, 12 carbon 6, 14 carbon 6, they may be different, they are isotopes because of their mass number, but they have the same chemical properties. And also we need to know that some isotopes, okay, if they are like really unstable, so we will just say some isotopes are unstable, okay? And these isotopes, we call them radioactive, okay? Now, some use of isotopes, I'm just gonna list anything. Uses of isotopes is that they are an energy source. Okay, we use them in tracers. So for example, if you want to trace the human body, you give a person a pill with an isotope so that you'll be able to use it in whatever, and also for dating. Now, another simple thing that was mentioned was about cations and anions. Okay, we know that cations, they lose electrons, okay, whereas anions, they gain electrons. So that's pretty much it for chapter 7. Thank you guys for watching. I hope you enjoyed and have a wonderful day.